So this will be part B of problem number 3 from the 2012 A, B, and BC exam. So we have this graph of f here, and we have this function g that's defined to be a definite integral where the function f is involved. And in part B, it wants us to find g prime of negative 3 and g double prime of negative 3, or state that those values don't exist. So if we're looking for g prime of negative 3, the first order of business is going to be to find g prime of x. So here's g of x. And the second part of the fundamental theorem of calculus says this: the derivative with respect to x of a function that's defined as a definite integral where x is the upper limit of integration is going to be found by simply taking that upper limit of integration and putting it in place of the t. So the derivative of this function is just going to be the integrand with x in place of the t. Basically it says that the derivative of a definite integral, those things are going to undo each other, and you're left with what was within the integral as your result. So in this case, it's pretty much a direct application of FTC Part 2 for the first part of Part B. If we want g prime of x, all we're going to have to do is take this x, the upper limit of integration, and put it in place of that t. So g prime of x is going to be equal to f of x. Now the thing that you have to watch out for when you're using this is if you have more than just an x in this limit of integration, like if you have an inner function of x here, since you're taking a derivative, you're going to have to actually use a little chain rule in addition to this. That doesn't really impact us here, but that could potentially be something you see in variations of this. So here's g prime of x. We wanted to know what g prime of negative 3 is. So g prime of negative 3 is going to be equal to, well, f of negative 3. Right? Just put negative 3 in place of the x and g prime of x. And so f of negative 3 using the graph, all right, well, let's see, that's going to be right here. So, you know, I guess that we can't just look at the graph and guess what that is. We should find the value of that appropriately. Let's find the equation of this line. So this line has a slope of, let's see, rise of 2, run of 2, right? I think I did that right. Yeah, I go from 1 with my y value to 3, and then I go negative 4 to 2. So yeah, rise of 2, run of 2. So the slope of this line is going to be 1. And then we know the point negative 2, 1 is on the line. So the equation of that line in point slope form, or any equation of that line in point slope form, would be this. Right? Y minus y1 equals m times x minus negative 4, so x plus 4. We want to know what the y value on this line is at the x value of 3. I guess I could use the equation, but I guess I know my slope now is 1, so I could use rise over run as well. Since I already have the equation here, I'm just going to go ahead and use it to complete the y value. But I could have used rise over run as well now that I think about it. We wanted to know the y value at the x of negative 3, so put that in for x, solve for y, and you get y equals, well, let's see, this is going to be positive 1 times 1, which is 1. Add the 1 over, and you get y equals 2. And using rise over run, yeah, that's the value we're going to get. Up 1 over 1 puts us at negative 3, 2. So we get a y value of 2 for that. So there is g prime of negative 3. We also want to know what g double prime of negative 3 is. Before we can find g double prime of negative 3, we need g double prime of x. Well, here's g prime of x. Just take a derivative of this, and there's g double prime. So the derivative of f prime, or excuse me, the derivative of f is f prime. So g double prime, the second derivative of g evaluated at negative 3, is going to correspond to f prime of negative 3. Well, what's f prime of negative 3? Well, on the graph of f, the value of f prime is just going to be indicated by the slope of the tangent line at whatever x value we sit at. The slope of the tangent line at the x value of negative 3 has to be the same as the slope of that line, which is positive 1. So this is going to be a value of positive 1. Now what would have been a little bit more interesting, which is probably why they include this in the directions, state that it does not exist, would be, what if they asked you to find g double prime of negative 2? Well, g double prime of x is f prime of x. G double prime of negative 2, you'd be sitting at this cusp. The slope of the tangent line at a cusp is undefined because it changes instantly from one slope to another slope. Using the definition of the derivative, the one-sided limits as we approach the appropriate value from either side aren't going to equal each other. This function's not differentiable. F is not differentiable at -2. So if it was g double prime of -2 we were after, that would not exist. But in the case of what we were asked, g double prime of -3, that exists. And that was a bad attempt at boxing it up. We found the value of 1 for that.